Okay, Martin and I are doing the Module 7 practice problems, and we were doing number 8. We realized, boy, you can really write a lot in the electron configurations. Wouldn't it be easier if you could just use like a shorthand for all of this to indicate where you are? The answer is yes, and of course chemists have thought of that because they do not love to write out long strings of electron configurations when they don't have to. So what they've done is, if you look at the periodic table, here on the far right, we see the noble gases. And the noble gases on this far right 8A column are the shorthand. So let's say, for example, in 8A, the practice problem, we were looking for titanium. Titanium is here.
4B.
In this space. So what you would do, instead of writing out the electron configuration all the way up to here, you actually take the one below it in column 8A. I hope this is visible. No, my camera's picking this up, which would be argon. And you take argon, and you write argon in brackets, and then you add the orbitals from there. So for titanium, you take Ar, and that would bring you up to here. It would be Ar 4s2 3d2 for titanium. Okay, so now we're looking at number 9, and we're going to do that. Starting with vanadium, letter A. Martin, where is vanadium on the periodic table?
It's to the right of titanium.
Great, so it's right there in that same block. So we're going to use, again, the bracket AR for the argon in the, which is number 18 on the periodic table. And then we're going to say 4s2 and then 3d3. Okay, that makes sense for you, Marty Man?
Yeah.
Excellent. That pleases me greatly. All right, the next problem, the next element is SN.
That's not him.
SN. Okay, good old SN is
smear. It's in 50. It's right here. So that's going to be IN in brackets, and let's see, it's 4s2.
It's tin.
4p2.
So SN is tin. Okay.
Cool.
So as Martin found, is number 50 in the periodic table. So the last 8A one is Kr. And what is Kr? Krypton. Okay, so it would be Kr. So then what do we come to? And we come to 1, 2, 3, 4, 5. Yeah, 5. So we say 5s2, right? That's rubidium and whatever Sr is, strontium. And then we go, so instead of 5, we call this 4, right? 4
yeah.
What?
4D.
4D, and it's all full up.
10. 4D10.
4D10. That brings us over to the p orbital.
So 4p, 5p. 5p2.
5p2 for tin. Okay, and then IN, which is indium. IN is number 49, so it's right next to tin. Okay, so it's going to look a lot like tin, right?
Yeah.
It's going to be krypton, 5s2, 4d10, 5p1, right?
Yeah.
And you understand all that? Makes sense to you? Okay, now we're going to look at number 10 and finish this up. we're asked what is wrong with these electron configurations. Or will you read the first one to me?
Okay, 1s2, 2s2, 2p6, 3s2, 3p7,
Ah,
which is incorrect. There it is. 3p7 does not exist.
yeah. Such a thing has never occurred.
3CPO totally exists.
Okay, so that's clearly an error. Okay.
C3PO.
Letter
Ooh,
B.
I
We
failed.
don't need to go any further. We found the error.
1s2, 2s2, 2p6, 3s2, 3p6, 3d10. I
Whoops.
think that's wrong. Yeah, it should be 2p10. Wait, no, that's wrong.
Let's look at our periodic table. Right? We've got the S's, we've got the D's, we've got the P's. So what should the order be?
3p6. It can't be a 3p. Oh.
Well, we can
Yeah,
have
the
3p6.
The D's, that D should
and that
not
should
be
be
in
followed by 4s2, right?
Right.
It shouldn't be followed by a D.
Yes.
Okay? The D level will come after the 4s2.
Yeah.
Okay? So that's the error there. Any questions about this?
No.
Thanks, Marty.